All right, guys, so today we are multiplying polynomials. So we already added them together. We've already subtracted polynomials. Today we need to know how to multiply them. Dividing is something you're going to do next year in secondary math 3. We just go as far as multiplying. So just a couple of things you've already seen. This is something that you've already been doing to a certain extent. This first example up here, if I have 2x, which is a polynomial, multiplied by 3x minus 4, which is another polynomial, you know that you take whatever's in front of the parenthesis and multiply it by everything on the inside. So 2x times 3x becomes 6x squared. 2x times negative 4 becomes negative 8x, and you're done. Okay? If I have just an x in front, I take the x, multiply it by everything on the inside. So x times 6 becomes 6x. X times negative x is negative x squared. Third one, 5h squared is in front of the parenthesis, and it gets multiplied by everything on the inside. This requires you to remember some of our exponent rules. 5h squared times 2h, 5 times 2 is 10. H squared times h is h cubed. Now 5h squared times 7 is 35h squared, because the 5 times 7 gives you 35. So we call this remember a polynomial that just has one term, we call a monomial. So what we have right here is a monomial in front of a binomial, something that has two terms. Well, the big thing this year that we're going to be doing in a lot of our work, a lot of the math that we do, is we are going to multiply two binomials together. So instead of just having a 2x to distribute to everything on the inside, if you look at this next example, you have a binomial, 3x plus 4, and then you have another binomial, 2x minus 5, and you are going to multiply them together, which actually goes pretty much the same way. The only difference is you are distributing both of the terms in the first parenthesis. So if you look at this, you take the 4 that's in the first parenthesis and you times it by the 2x, and you times it by the negative 5, and that gives you these two red numbers down below. But you also have to take the 3x that's in the first binomial and times it by 2x and negative 5, and that gives you the 6x squared and the minus 15x. So once you multiply things together, there's a note right here that says it's pretty common that two of those will combine together. So like the negative 15x and the plus 8x can add together to become negative 7x. So here's where you need to be careful. This is the first time we mix the world of adding with exponents and multiplying with exponents. So in this case, you've got to use the multiplying rules up here, but then you also have to use the addition rules to simplify after you multiply. So let's do a couple examples. It's not nearly as complicated as it seems. So one of the phrases that I'm going to use on these problems is if you come to me and you say, hey, I've got this a plus 3 and this a plus 2, I don't remember how to multiply them together. What I'm going to tell you is that you need to FOIL. That's the phrase I'm going to use a lot. It doesn't, mathematically, it doesn't mean anything, but it's to help you remember what to do. Kind of like railroad tracks don't mean anything in math, it just helps you know what to do. So what FOIL is meant to help you remember is to multiply everything in the first parenthesis by everything in the second parenthesis. So you take this a and times it by that a, and you get a squared. Then you take this a and times it by this 2, and you get plus 2a. Now you switch to the second number, this 3, and you times it by a, and that gives you 3a, and then you take the 3 times it by the 2, and you get 6. Now before I finish, I want my answer to be in standard form. So I start with the biggest exponent, which is a squared, and then I combine my a's together. 2a's plus 3a's is 5a's, and then I've got the plus 6 at the end. Okay, let's try the next one. 4r plus 2 times r minus 1. I take the first number in the first parenthesis and times it by the first number in the second parenthesis. So 4r squared. Then I take the 4r and I times it by the negative 1, which gives me negative 4r. Then I take the 2, times it by the r, and that gives me 2r. And then I take the 2, times it by the negative 1, and that gives me negative 2. And again, I want to write my answer in standard form. So I start with my biggest exponent, 4r squared. And then these two in the middle are like terms, so they add together, minus 2r, and then I've got a minus 2 at the end. Okay, let's try it again. 2x plus 3 times 2x minus 3. Something interesting happens on this one, which you'll hopefully start to pick up a pattern when you see what happens here. 2x multiplies by 2x, that gives me 4x squared. 2x gets multiplied by negative 3, that gives me negative 6x's. Now I switch to the second number. 3 times 2x is positive 6x, and then 3 times negative 3 is negative 9. Now I just want to simplify, combine like terms. 4x squared goes first. The negative 6x and the positive 6x add together and become nothing. They cancel each other out. And then I've got minus 9 at the end. Okay. Second one. Well, not second one. How did I get to 2? Fourth one. X times 2x is 2x squared. X times negative 3y is negative 3xy. I like to put the letters. It doesn't matter if I do negative 3yx or negative 3xy, but I like going in alphabetical order. Then I do negative 5y times 2x, so that's negative 10xy. I did not do a good job preparing for this problem. I got to scoot it over. And then negative 5y times negative 3y is positive 15y squared, because negative 5 times negative 3 is positive 15. Y times y is y squared. Now on this one, my middle terms go together. So I'm going to start with my 2x squared again. And then negative 3xy and negative 10xy gives me negative 13xy. And then I end with plus 15y squared. Okay. Same idea, but a little bit of different notation. So this is called a binomial squared, which sounds a little bit scary, but all I'm doing is I'm taking a binomial, 3x minus 1, and I am squaring the binomial. Now, if you remember, when you square something, it means you multiply two of them together. So 3x minus 1 squared means 3x minus 1 times another 3x minus 1. And then I just do what I've been doing. Everything in the first times everything in the second. 3x times, where'd my pen go? 3x times 3x is 9x squared. 3x times negative 1 is negative 3x. Negative 1 times 3x is negative 3x. Negative 1 times negative 1 is positive 1. Then I put things in order and combine like terms. So 9x squared is going to go first. My negative 3x and other negative 3x combine to be negative 6x's. And plus 1 is all by itself at the end. Okay? So let's do that again. 5r plus 8 squared. So that just means parenthesis 5r plus 8 multiplied by another 5r plus 8. So 5r times 5r is 25r squared. 5r times 8 is 40r. 8 times 5r is another 40r. 8 times 8 is 64. So when I combine like terms and simplify, the r squareds are the only one. The r's add together to become 80r, and the 64 is left at the end by itself. Now they'll try to trick you by what's called a binomial multiplied by a trinomial, which is just more of the same. The difference is this time I have a binomial getting multiplied by a trinomial. Now in 7th grade, it didn't matter if you put a 5 in front of x squared plus 2, the 5 would get multiplied by everything. If you put a 5 in front of x squared plus 2y plus 2, you would multiply the 5 by everything in the parenthesis. We're doing the same thing. Just because one of them has 3 terms this time doesn't make a difference. I still take everything in the first and times it by everything in the second. So x times x squared. I'm going to change colors so I don't mix up this problem next to us. Let's go ahead and go with the, no, come on, pen, where are you? X times x squared is x cubed. X times negative 2x is negative 2x squared. X times negative 7 is negative 7x. So x has been multiplied by everything. Now I got to do the same thing with 5. 5 times x squared is 5x squared. 5 times negative 2x is negative 10x. 5 times negative 7 is negative 35. Now I have a lot more terms to combine, but that's it. It's the same idea, just combining more things together. I start with my biggest one, x cubed, and then I look for x squareds. So there's one, there's another one. So negative 2 plus 5 is plus 3x squared. Now I look for regular x's. I've got negative 7 of them right here and negative 10 more, so that's negative 17 x's. And then I've got my negative 35 at the end all by itself. So my answer is longer, but it's just the same math. It doesn't matter how many are in the first one and the second one. You multiply everything in the first by everything in the second, okay? What happens if there's more than one binomial and a trinomial? In this case, I've got a monomial and then a binomial and then another binomial. Now, it doesn't matter which order I multiply in. Remember way back when you learned that if you had something like 2 times 4 times 3, it doesn't matter if you do 2 times 4, get 8, and then times by 3 and get 24. You could also do 4 times 3 and get 12, and then times by 2 and get 24. So it doesn't matter which order you multiply in. What does matter is that you made a mess of my erasing there. What does matter is that you multiply everything. So let's start with, let's just start with what's in front. I'm going to take this 3x, and it's going to get distributed into the parenthesis that it's attached to. It is not attached to this one, so I don't multiply it to that one, just the first parenthesis. So 3x times x becomes 3x squared. Whoops. 3x times 8 becomes 24x. Now I've got to take that same number and multiply it by 3x minus 4. So all those numbers I just got, I distributed the 3x into the x plus 8, so now I've got to multiply that by 3x minus 4. So 3x squared times 3x is 9x cubed. 3x squared times negative 4 is negative 12x squared. 24x times 3x is what? 72x squared. 24 times negative 4 is negative 96x. And combine like terms. No, let's see, just one x cubed. I've got a couple x squareds, negative 12 and 72 becomes 60 x squared. And then I've got a negative 96x at the end. Okay. Now, if I had done this in a different order, you don't need to do it, but if I had done this in a different order, so if I had 3x times x plus 8 times 3x minus 4, if I had chosen to multiply this part first, so I have a 3x out in front, and it's going to get multiplied by x times 3x, 3x squared. X times negative 4, negative 4x. 8 times 3x, 24x. 8 times negative 4, negative 32. Now I've got to multiply by 3x. 3x times 3x squared is 9x cubed. Hey, that's what I got up here. Not up there. That's what I got up here. 3x times negative 4 is negative 12x squared. Hey, that's what I got up there. 3x times 24x is 72x squared. That matches up there. And 3x times negative 32 is negative 96x, just like I got at the top. So it doesn't matter which order I multiply in. I just have to be careful that I multiply everything, okay? 3 times x minus 1 squared. I'm not going to do this one for you, but here's how you set it up. You have a 3 in the front, and then you have an x minus 1 times another x minus 1. And you can choose to multiply that in whatever order you want. Okay, this says to create a polynomial in terms of x that represents the area of the rectangle. So I've got a rectangle. I want to write this in terms of x as the area. So area means length times width. So I need to do 5 multiplied by 2x plus 3. So then I just distribute the 5, and I get 10x plus 15. So super easy to write that polynomial, right? This one says if the area of the rectangle is 45, what must x be? So if I know that when I multiply all of this together, I end up with 45, I can write that equation. 45 equals 10x plus 15. So then I minus 15. I'm just doing railroad tracks now, minus 15. So 30 equals 10x. Divide by 10, x equals 3. Okay, you've got some homework problems. If you need more room, then use another piece of paper. Take pictures of your work when you are done, and make sure you submit on Canvas.